Hello and welcome to this webinar on accelerating NFV, SDN and SD-WAN adoption for telcos and service providers. We have a pretty packed agenda with guest speakers for you. So we'll go through a quick round of introductions. Then we'll have an overview of the trends and challenges in this space, followed by a solution as well as a demo. And then we'll open this up for Q&A. We expect this to last anywhere from between 50 to 60 minutes, but we'll close at the top of the hour. And in the interim, if you have any questions that you are coming through with, please click on the tab that you see at the bottom of your screen. You can send us the question, and we will be having experts stand by to answer them for you. And at the end of the webinar, we'll also have a drawing, and 3 lucky attendees will get Amazon gift cards sent their way. With that, I just wanted to have a brief introduction about our company, Quali. For those of you who are not familiar with it, we're a venture-backed startup, and we're focusing on automation, mostly for cloud, DevOps, things like that. And our flagship product is called Cloud Shell, and what it delivers is sandboxes. These are replicas of production environments. We're about a 115 member company with 300 plus customers, with offices here in Santa Clara, California, as well as in Israel. So with that, let me introduce to you our panel for today. I'm Shashi Kiran, and joining me will be Pascal from Quali. He's going to be one of the speakers talking about, obviously, the Cloud Shell solution. But I would really like to welcome our guest speaker today, Jim Flager. He's a distinguished architect at Verizon. And so Jim's really going to be talking about NFV, SDN trends as he sees it from a service provider perspective. Hello, Jim, and welcome.
Great, thank you.
And the second speaker that I'd like to welcome is Aaron Edwards. Aaron's from CloudGenix. They're a startup based here in the Silicon Valley as well, focused on the SD-WAN space. So Aaron, welcome, and I think you'll be sharing about some exciting SD-WAN trends.
Yeah, thank you. Very nice to meet all of you.
So that's really a pretty strong panel that we have here. And with that, what I wanted to do before we jump into some of the more deeper stuff was help set the context. There is a fair bit of noise today in the SDN space. In some ways, it has gone through the hype cycle that many of us are familiar with, and we're seeing adoption happen. But there's still a lot of confusion with regards to the taxonomy, some of it from before. So this representation that you see on the screen here is not a stack by any means. It's really a way for us to frame the conversation and look at the taxonomy. Broadly, we're looking at software-defined infrastructure, which we go by SDI. Some say SDX for anything SDN. And across a lot of the infrastructure elements that are getting software-defined, you do have network, compute, storage, security, and other elements as appropriate, all of which have a management, automation, orchestration component, which could either be cloud or on-premise or both. So in the context of this webinar, we're mostly focused on the network piece of it. And underneath the network, as you can imagine, there is the SDN piece or the SD-WAN piece. So here we are seeing a lot of adoption and excitement. And then there is the NFV piece, which is the network function virtualization, which also is a lot more focused, and we're seeing a lot of good traction there. So what is important to know, though, is the software-defined architectures can vary depending on which vendor you want to talk to, or which standard you read upon, or which protocol ends up getting supported. And generally, it's fair to say that use cases drive architecture, so it's really important to relate it to your use case. Secondly, we do see in the context of the IT stack, there is a fair amount of disaggregation that's happening. You could have certain vendors looking at it as a monolithic stack, others are disaggregating certain components of it. And what we are seeing is, with this disaggregation, cloud and automation are really driving that innovation as well. And thirdly, while the whole conversation of SDN began in the data center, and today we see variations of it called software-defined data centers, It is in the WAN that it is probably seeing the most adoption in the context of enterprises. And in the context of service providers, NFV is very well defined, and a lot of service providers are throwing their weight behind it. And when we look at network function virtualization, it's easy to see why it is actually getting that traction, because on one hand, unlike SDN, which originally began with one protocol and suddenly there were different variations of it, NFV started off in the standards body with ETSI, number of service providers including Verizon actually coming and contributing to the standardization of it. That group today has over 100 members, and there are different specifications bodies which obviously get into IEEE and other bodies too. The interworking and the cooperation between different standards bodies is quite important. So what is a good motivation for them is to look at what happened in the context of the data center with virtualization and to see if such benefits of agility, of efficiency could be gained by virtualizing functions that were traditionally hardware-based appliances. So obviously service providers see a lot of value in that, and that's the motivation for NFV. I just wanted to share some high-level market trends in here. So clearly, based on different research reports, we do see a fair amount of growth projected for both SDN and NFV investments between now and 2020, for example. It's a very healthy double-digit growth that's projected, and obviously a lot of revenue that is attributable. Now, these revenue numbers are very subjective, so I would encourage you to take it with a grain of salt, because that's really how vendors would end up reporting revenue on what is SDN or NFV attributable, and some of those, or maybe a lot of them, are still hardware centric as well. Having said that, it is important to know that there's a tremendous amount of promise and the trajectory is positive. And if you look at the image on the screen from 451 especially, they are saying that SD-WAN is going to go prime time in 2017 based on the research that they did in 2016. And again, there are some challenges with SDN and NFV with wide-scale service provider deployment, but they do see that both service providers that are actually encouraging and adopting innovation as well as taking a much more proactive stance will end up benefiting significantly from it. So with that said, I want to now hand the ball over to Jim and have him go through his perspective from the vantage point of Verizon, as well as him personally being a thought leader, and walk us through what he's seeing. Jim?
Great. Thank you, Shashi. Let me first start talking a little bit about Verizon and why we're here. Most people, when they think of Verizon, they think of our wireless business, which is certainly a large portion of our business. But like our customers, we operate a complex business and we share many of the same challenges. Besides the wireless, we manage a globally distributed workforce. We have a large real estate retail footprint, an expansive fleet of vehicles, and a complicated supply chain. We understand the challenges that our customers face because we face them too. As a result, we have a wide range of operational and delivery experience. We're driving innovation through our capital investments and new product development, both in the wireline and in the wireless spaces. We collaborate and co-invent with technology partners and customers on solutions that are easy to build, quick to deploy, and simple to manage. Our IoT solutions are transforming businesses through an aware and autonomous network that provides actionable insight and better business intelligence. We have a workforce of over 177,000 employees, so we know that distributing access to them across the world is critical. We also manage a complex and dynamic supply chain using technology to control operational costs and to improve efficiency. Our network fleet merges our GPS technology with engine diagnostics to help control costs by reducing fuel consumption and idle time across our 28,000 vehicles. We also own and operate 1,700 retail stores across 82 countries. We also help keep our customers connected to their customers, to their partners, and to their employees. And this also includes 113 million wireless connections just in the U.S. In security, we're managing and analyzing millions of security events across our network, and we've also led more than 500 forensic investigations in 2015. Every year, we summarize our findings and make them available to the public in our highly regarded Data Breach Investigation Report, or DBIR. In fact, the next version of this is due to release tomorrow. As an information and communications technology provider for 99% of the Fortune 500, we're a trusted partner offering innovative solutions that deliver the promise of the connected world. Now, I'm here today to talk specifically about the software-defined networking and network function virtualization. And these are two technologies that Verizon's very excited about. Can we get to the next slide, please? And we're excited about these because they have the potential to improve the quality of our services while simultaneously reducing their costs. These are technologies that we're both using on our own network, as well as making them available to our customers through as services. Now, first, software-defined networking, or SDN, is focused on separating the control plane, which is the piece that determines where and how traffic is sent, from the data plane, which is the piece that actually moves the data across based on the control plane's decisions. This separation is what enables us to centralize administration of the network. In other words, SDN makes it possible for us to take the behavior of how traffic should flow in the network, put it into one central place, instead of having to configure each individual router and switch independently. From there, we can then implement very complex behaviors that would be difficult or potentially even impossible if these devices were acting independently. One of the earliest of our products to do this was our SD-WAN offering, or our software-defined wide area network. This is where we manage our customers' public and private cloud edge networks, so just the devices that connect to the internet, and not the devices inside the networks. By managing these edge devices, we're able, and tying them to centralized cloud-based administration, our customers can accomplish several things. One example of new behavior that they can have is very efficient use and management of connections to remote sites. Especially when you have a large number of small branch sites, like in a retail setting. Without SD-WAN, all of the traffic from those remote sites would typically have to be sent back to the customer's headquarters or to some central data center before it can then go out to the internet. So you're sending all this traffic without regard to what the content of the traffic is. After implementing SD-WAN, we're able to do complex traffic shaping and management, where critical traffic can be routed from remote sites back to the company headquarters, or directly from the remote site securely to cloud services like Salesforce. While non-critical traffic, like YouTube streaming, could be routed directly to the internet from the remote site. And then if bandwidth becomes tight, maybe in the event of an outage, non-critical traffic can be dropped at the site altogether, conserving that limited bandwidth for the critical business traffic. The next level of complexity for Verizon came when we wanted to centralize control of even more network functions, such as firewalls and load balancers. This is what led to the adoption of NFV, or network function virtualization. So now we're going to break out all of the functions of the network elements and make them available in the cloud, or potentially on a generic x86-based white box. This means we no longer need vendor-specific hardware and software for things like firewalls or load balancers, but instead we can use commodity hardware and even open source software. And then the final step for us is if we take these NFV white boxes off of our customer premises and move them into our cloud, that's our new virtual network services offering, or VNS. So in a nutshell, we're taking the best of SDN and NFV technologies to solve real business problems that our customers face, as well as ourselves, and speeding the business of the delivery of business along the way. We're taking the centralized control that comes from our SDN, combining it with vendor independence through our ability to decouple software and hardware using NFV, and combining the two of these together to create business results that matter, lower cost of operations, and increase service delivery velocity. Now, the old way of delivering all of the services like security and WAN optimization, and even just simple routing, was to always buy the latest hardware, and then you have to manage it, power it, and ultimately you have to deal with each individual device vendor, because typically you're not going to buy all of these from one single company. Now today and going forward, VNS allows us to offer significant business advantages, such as pay-as-you-go pricing. You can scale up or down depending on what our customers' needs are. And this also converts the cost from a capital expenditure, CapEx, to operational expenditure, or OpEx. You can then take a single piece of hardware that has the compute power to run multiple services, give it centralized control, and all run everything on the same platform. And this all results in a cost savings by taking multi-vendor options where our customers can mix and match best-of-breed technologies from whatever vendors are appropriate to their situation. But Verizon is able to manage all of the business relationships for them. If we compare this to an existing customer premise solution, using VNS highlights the value associated with this business innovation. The large expense and disruption associated with a network refresh can be replaced with pay-as-you-go pricing, allowing costs to easily be amortized across the business cycle. No longer do you have this large upfront cost of purchasing hardware and then the additional time and effort spent to do that upgrade. Now you can do rolling upgrades with pay-as-you-go pricing. Existing premises space, power, and labor resources can all be reduced and pooled into a multifunctional cloud network that has a single universal device on premises. By having that single device, it also means that it's much easier to manage inventory of spare hardware. You don't have to keep a lot of different components or full units from a bunch of different vendors. The ability to mix and match all of these latest technologies from multiple vendors results in a technically superior design, but at the best possible price point. Now, customers don't need to manage and to test all of this hardware with vendors or worry about compatibility or the relationships, because Verizon's able to handle all of that for them. The biggest advantage that we're offering, though, is that this is delivered in an OpEx model versus a CapEx model. Not only is this for the hardware, but even the software licensing can be delivered this way. This means customers now get to future-proof their networks by decoupling the hardware and the software at the service level. They purchase the right from us to access the service without ever having to commit to any licensing, which allows them more flexibility. An additional advantage for us is that because with everything being software-based, it's now trivial for us to add monitoring to these devices. So now all of our VNS-related services come packaged with full network management and hardware support. Customers don't have to worry about anything now. One single monthly price it will make the billing simpler and makes the consumption more flexible. Now, like any new technology, SDN and NFV are not without their challenges. The first challenge that Verizon faced was interoperability. There are a number of different hardware and software vendors in the mix, and not all combinations support all features. We wanted to remain vendor neutral in order to offer our customers the best-in-breed solutions at multiple price points and capabilities. Additionally, nearly all of the implementations that we do are what are called brownfield, meaning that there's already some equipment in place that we need to either adopt or integrate with. So anytime you have this old and new technology meeting, that's an opportunity for things to go wrong. For these reasons, testing in our labs is vitally important to us. We test both the bespoke offerings that we sell, as well as any unique customer-specific situations we find ourselves in. We also often find that before we can help our customers implement NFV, we first have to help them assess the current state of their network. It's rare to find a customer who has a complete picture of all of their network hardware, circuits, and traffic flows. Usually we have to work with them to discover and document everything to ensure that nothing gets lost in that transition. Now, that transition can be made a little bit easier because unlike a traditional network upgrade, you can do this in small pieces and roll NFV out across the network in phases. And finally, we struggle to keep pace with the rapid rate of technology, just like anybody else in the industry would. We're routinely adding new hardware and software as well as new features to our offerings, and all of that has to be rigorously tested before release. At the same time, we're taking our very experienced sales and services teams and retraining them in this new paradigm, and that includes giving them hands-on labs to work in. So I hope that you've gotten from this just a good overview of how NFV and SDN are changing the landscape both for our customers and for Verizon ourselves.
Jim, thank you so much for that overview. I'm sure a lot of your peers in the industry can relate to that, and I'm sure several more can learn from it. With that, I would like to now invite Aaron to talk about the SD-WAN trends, but before that, perhaps a brief introduction to CloudGenix as a company.
Sure. So again, hello everybody. Thanks for having me here, and glad to meet with everyone that's on the webinar. I want to talk a little bit about CloudGenix. We've been around since 2013. As Shashi said, we're a startup here in the Valley as well. But already we've seen phenomenal growth in the software-defined wide area network space, which was the problem we started out to solve. We're processing over 5 billion transactions per day in customer networks across the globe. We're deployed in every continent, sans Antarctica, but we're working on that. And we have a market cap of customers in the almost $500 billion of market cap across all of our customers worldwide. One of the premises that we were started upon was looking at traditional networking. If you look back at how networks have been built since even the mid to late 90s, everything was a standard hub and spoke model. You would have customers with their apps living in the data center, building their connectivity with MPLS, or even going back further, frame relay or lease line connections, out to their branch offices or remote retail or service locations. But as a network has changed and evolved, now you've seen that you have a whole host of different technologies coming across the networks. Apps no longer live only in the data center. They may live in the data center. They may live as a public cloud SaaS offering. They may live as a hybrid cloud offering where a customer is consuming a service provider or a cloud service for a virtual data center in the cloud. The connectivity to connect remote offices is no longer straight MPLS or private lease line. It's now internet connectivity. It's LTE connectivity. On top of that, in the branch offices, your expectations of environments have changed. No longer do you have just mission-critical apps going back to the data center. You have video applications, rich media applications, omni-channel, where people want to get high-speed data and rich experiences. You have people and customers even bringing in mobile devices, tablets, trying to get access to more and more services at these remote locations, and companies wanting to provide access so everyone has a seamless, pervasive, easily up experience. One of the big problems with providing and dealing with these different types of networking issues with the traditional legacy network is that you end up having two major issues. Number one, if you look at the way traditional routing protocols have evolved since the 90s, it's been a bolt-on approach. So as routing is needed to take into account performance and availability and uptime, the protocols have been constantly extended to where now we have this alphabet soup of routing protocols and availability checks. On top of that, the other thing is security. So if customers want to be able to provide functions or capabilities in the remote office, if they use traditional networking, they ended up racking and stacking everything in a branch office or in a data center. You really had this kind of sliding approach where I throw everything in the branch that I need to inspect, or I have everything in the data center that I want to be able to inspect and manage and monitor and force all the traffic through the data center. On top of that, criteria for how customers evaluate the success of their network is changing as well. Used to be that network teams were being tasked on, can I get a ping packet from one end of the network to the other? Is that sufficient? Great, I've got 5 nines of uptime. But today, networking teams are getting more and more tasked with, are my business critical apps up and available and working? Can my end users get to our quoting system? Can they get to our ERP or CRM systems? Can they get to Salesforce or Office 365 and get their email? And that's what this is the problem that SD-WAN and CloudGenix specifically set out to solve. So one of the things that CloudGenix does is we say we have an application-driven WAN, and this is how we help solve this SD-WAN problem. We're saying that the fundamental unit of operation that people care about at their remote offices are applications. So first thing we do is everything is commodity off-the-shelf x86 with CloudGenix. So whether it's virtual, physical, turnkey appliances, it's all the same. And then you bring in your hybrid WAN. So you bring in your connectivity from whatever WAN provider or whatever resources that happen to be available, whether they be private leased lines, MPLS, even frame relay. We still have a customer using frame relay today. I want to get them off it. But internet, LTE, everything that you have. And then finally, now you do the last part of it, which is CloudFast, which is saying now for all of these different connectivities for these sites, which applications do need to be made available? On top of which applications need to be made available, what are the best paths for those applications individually? And route each of the applications based on performance of the app and availability of the link and end user experience in real time.
So those, thank you, Aaron. So those
Yes.
are clearly, burning problems that you're solving. And in a way, the trends that you and Jim articulated, as well as the problem statement, is fairly similar across what Jim is seeing and what you're seeing, at least from your customer base. Mm-hmm. Now, what we wanted to do is really take a look at the problem statements that Jim articulated earlier, as well as the trends that both of you shared, and compare it with what many are seeing across the industry. So today, as we saw, there's a significant amount of promise that SDN and NFV brings in. Today, we're seeing almost 2/3 of service providers still conducting lab trials on their data centers respectively, and obviously that will translate into production environments later. And we also see a fair amount of bare metal switch ports, which means hardware isn't going to go away. Mm-hmm. It is going to go commoditized, and there will still be some linkage that you do need to bring in across the stack. What is interesting, though, as can be seen from this slide, is there's a bit of a drop in terms of the number of trials that were undertaken in 2015, certainly in the context of service providers, to what we see happening in 2016. And so this conveys a couple of things. One is it does talk about the maturity, and the second aspect is really some of the challenges. Both can contribute to fewer amount of trials. When we dug a bit deeper, there is certainly a notion that going to production, live production, is a lot more difficult than it is anticipated after undergoing these trials, and it consequently takes much more time. So this is reinforced in multiple reports, including this one from IHS. And the fact is, today when we do the trials, it's really in a controlled environment, but when you get into a live production, that's where the stack that Aaron shared earlier as the bolt-on approach, that stack hasn't gone away. That's still very much in existence in a lot of customer environments, and you have to deal with it. So that really brings up this real-world paradox where you compare the positives of SDN and NFV and the promise that they bring with the reality of the world today in the real-world situation. So on one hand, as you can see, software-defined networking brings a lot of simplicity in the way that it is architected, in the way that it is managed, in the way it is measured. But again, we saw that there is a diversity of standards, which means it does become a bit of a challenge, especially when you want to bring in different standards and vendors to interoperate. Likewise, NFV brings in a lot of agility, but when you go down the path of performance and scaling, it is still somewhat hardware dependent. And so you want to figure out what is the boundary of your ability to scale with virtualized functions versus when, as a service provider, you'd want to bring in a hardware element to it, and maybe for different workloads. Aaron talked about the quick SD-WAN rollouts and the companies they had. But again, MPLS investment has been going on for several years. It's been a decade-plus old technology, and it's hard to rip and replace some things. Even as SD-WAN comes in, it's always easy to roll this out in greenfield environments, but brownfield is where the challenges begin, where you have to interoperate with legacy. We talked about multi-vendor interoperability as well, and likewise, any new capability, any new technology, it's easier to roll it in greenfield. And what we want to discuss is how to solve that complexity in terms of ensuring compliance in a brownfield and especially heterogeneous environment. And so the hard questions to answer therefore is, one, how do you handle legacy, even as you're introducing something new, cool, cost saving? And here we have to be in a position to replicate the real world brownfield environments early on in pre-production for test and compliance. Number two, how do you standardize the workflows? Because even as you introduce newer technologies, the human workflow component of it cannot change as rapidly. Sometimes it's easier to upgrade technology, but the workflow within an organization, the hand-holding, the collaboration, as well as the back-end systems, that's where it becomes a bit complicated. And these need to be addressed to solve the issue of rolling out faster and, more importantly, at scale. The third is around complexity. So the more you see the interworking required between the bolt-on approach, many of which could be a series of band-aids over many years strung together, with something that's entirely new. How do you still bring predictability into the system and minimize the risk and complexity for embracing and adopting newer technologies? And I'm talking about SDN, SD-WAN, and NFV are still relatively new, and a lot of people going from trials to real-world deployments. So to address some of these, I would like to invite Pascal now to talk about what can sandboxes do to preserve compliance and handle the tough questions we faced.
Thanks, Shashi. So what would a complete solution look like if we had to address these questions? I think we've heard some recurring theme from Jim, Aaron, and Shashi. And at Quali, we've been working hard with the concept of Cloud Sandbox. So what is Cloud Sandbox? It's essentially a concept to define the environment of a network tester that we'll use to validate a specific use case. So it includes the physical and virtual infrastructure, the application workload, the data, the test tools and services. And that means both legacy and new type of environments can be supported in the same type of solution. And so a complete sandbox solution includes a UI for the designer or architect to model a blueprint and attach automation and orchestration resources. And the system includes a reservation and scheduling system for physical resources as well. Once a blueprint has been created, it can be published to a catalog and deployed to the cloud of your choice for the virtual resources. So vCenter, OpenStack, Azure, and AWS are all supported out of the box. Another important aspect is the added governance and control for the creation of those standard blueprints. And we heard standardization as something that will help a lot moving forward with the adoption of those technologies. And we also provide a BI tool that gives the IT or lab administrator visibility on resource utilization, another challenge, as well as cost and trending for all the sandboxes that have been deployed. And finally, blueprints can be activated through a RESTful API or accessed through an end-user self-service portal. So let's go over the process. What does it take to create a set of sandboxes for the rollout of an SDN or NFV transformation? So the first persona involved would typically be the infrastructure owner, who would collect information about the network infrastructure that may be physical but also virtual, and align also his organization to the different roles. The second step is to model these assets in the cloud management platform and build some automation around it. So once that step is complete, the network architect will design the blueprint and publish them in a self-service catalog. So these blueprints are now available for the QA team for consumption and deployment. And finally, the infrastructure owner has the ability to showcase the management the reports about the efficiency of the SDN or NFV implementation in terms of cost savings, ROI, and resource consumption. So as you've seen, one of the first prerequisites before you get started in this journey is to know what you have, know your assets. And here we're going to just review some of the important concepts behind this process. The first one is, as much as possible, to do some auto-load and discovery of these assets using, for instance, standard protocols like SNMP that we support at Quali. And then if you already have a DCIM tool, of course the best is to integrate it with a Cloud Sandbox system or Cloud Sandbox system and quickly load it into the database. Now, another thing important to mention is that Quali is using the Tosca standard to model those assets and simplify the new device configurations. So if you already have some usage of Tosca, which is pretty current in the industry, you could benefit from that as well. And all the virtual assets can be modeled with the choice of multiple cloud deployment options. So when this process is complete, you will have some insights on identifying some of the best candidates, network functions that you could virtualize. So the next step is to create a blueprint template. So a blueprint template will effectively serve for deploying your sandbox, and this is the very first step. It's quite simple. It's based on the premise that the network architect should be able to just drag and drop elements from a resource and app catalog onto the canvas, whether it's physical or virtual assets that are represented, and connect them just like you would draw on a diagram in Visio or even on a napkin. So each element has pre-configured automation capabilities, and once the layout is complete, all you have to do is decide on which parameter you're going to publish as inputs, such as the NFV version of the router firmware version, and then publish it to the self-service catalog so that it becomes available for all the users to consume. So in this layout that you can see on the screen, you can see a number of physical resources like Cisco routers that would be reserved, and then virtual application components, including a virtual CPE, that will be deployed at the time of instantiation of the test, and tools as well, such as IXOD and Breaking Point, that will be used once the sandbox is active. So another important aspect is also the connectivity between these elements that's defined in the blueprint. So in this case, we have a number of VLAN segments and SD-WAN policies that will be configured by the orchestration at deployment type, so that all those links are essentially automated and dynamically instantiated. And I will cover this example more in depth when we go over the demo. So one of the key tenets to increase repeatability and decrease the risk is to offer a standard validation platform and workflow that applies to both legacy and the new software-defined environment. So once the blueprint I described in the previous slide has been published to the Cloud Shell catalog, it's now available to the end user according to user group permissions. In this case, we created an SDN NFV blueprint category, and that's what you can see here. And each blueprint in this catalog will be accessed and deployed using a common set of policies, APIs, and orchestration workflow that streamline the process across the whole organization. So now, true acceleration of the rollout of these new technology will not happen without automation. So in other words, automation doesn't only pertain to SDN and new shiny technologies, but also to everything that you have before that. So in order to bring about the benefits of this accelerated certification, you need to bring in agile best practices as part of the DNA of your end-to-end certification process. So when it comes to sandboxes, what does it mean? The main goal is to minimize the number of blueprints while maximizing the number of permutation possible. So the way to do that is by simply exposing specific parameters of resources in your blueprints as input variables. For example, an NFV blueprint could have an input parameter that allow a user or an external system to automatically apply a specific version of the virtual CPE being tested, or in which cloud do you want to deploy the virtual machines. So out-of-the-box orchestration provides the foundation for the setup and teardown of all the blueprints, and extensibility, the way to customize it with your unique use case needs. And finally, the solution integrates tightly with other DevOps tools in your organization with our REST API that enables the automated deployment and teardown of the cloud sandboxes. So one of the cornerstones of this process is for the IT administrator to get visibility on the effectiveness of this SDN technology deployment. So as Jim mentioned, if you don't know what you have, then it's difficult. And our solution provides the ability to run advanced interactive reports and give insights on virtual and physical resource consumption over time. This is a key component to ensure that your assets are being used at the most efficient rate and the lowest cost. For instance, I'd like to find out what was the overall consumption of the capacity of virtual machine over the last month and the performance of my NFV deployment compared to the legacy environment performance. So these provide key insights to management to validate the ROI of NFV or SD-WAN investments. Now we'll jump into the demo. So just to set
In this demo, I will show how a service provider can quickly certify a new version of Virtual CPE NFV as part of a service release plan. I will first log on as an end user to the Cloud Shell Self-Service portal. We can see the list of blueprints available to my user. I will now select a blueprint in my NFV catalog representing a virtual CPE connected to two remote sites, Houston and Dallas. These sites are themselves connected to a core network using SD-WAN technology. In the backend, we have a hosted application with a Hadoop backend and an application server in the San Jose data center that's modeled by this network segment. We have also represented a number of test tools from Ixia, IXLoad, the virtual traffic generator, breaking point, security traffic generator, and the performance analysis IXChario. We can also check the instruction pane that will give you all the elements needed to operate this blueprint. So let's now deploy this blueprint. As an input, I will select the version of the virtual CPE that I would like to certify. In this case, version 1.1. The orchestration setup will now run and deploy all the virtual machines in the cloud of choice, in this case, OpenStack. The virtual CPE software will be loaded on the deployed VM from its repository, and the network connectivity will be configured, including VLANs and subnets, as well as security policies. And we can see what's happening in real time in the output window. So once the setup is complete, the sandbox is now in active state. The latest health check status is reflected on resources. And there are also some interactive commands bound to each resource that a user can run to execute some test. For instance, we'll run a performance test using IXLoad traffic generator directed to the virtual CPE. Once the test is complete, we can get the statistic running another command. And this command will attach a report that has been generated by the Ixia IXLoad tool directly onto the sandbox. So we can see all the results of the test that we just run directly from the Cloud Shell workspace. You can also access the console of any of the resource by using the shortcut on the Sandbox. So here I'm going to SSH to this Linux platform, and now I am directly on the Linux console of that server. Now if any changes are made during the test on the Sandbox environment, I can run a new orchestration command that will take a snapshot and give me the opportunity to resume that test at a later stage or promote this environment as a new blueprint that I can use for my end-to-end testing or even deploy to my staging environment. So at the end, we're going to have a similar orchestration process that will tear down all the setup, which means removing all the virtual machines and disconnecting all the links and reallocating all the resources to the public pool. And this entire workflow can also be completed using the REST API. So you could actually run all these Sandbox deployment from a pipeline tool such as Jenkins into a continuous integration workflow. So this demonstration showed how a virtual CPE environment can be dynamically provisioned and certified very quickly with low overhead.
So that you've seen the demo, I'd like to summarize and give you a little bit of a run through of a process if you want to get started now and adopt all those best practices. So there are 3 simple steps that you can take immediately, and of course we'll be happy to assist you along the way. So the first step is, as you figure out your inventory, look at what are the low-hanging fruits for functions that you want to virtualize, lower risk and highest return. The second step involves defining your compliance criteria for deploying these new solutions in terms of performance, scalability, and security. When this is done, identify a few scenarios that will be modeled as your standard blueprints and workflow. And finally, the last step involves the deployment of these cloud sandboxes that can be staged in multiple phases to decrease the risk. So I just wanted to go quickly over an illustration of how such approach can be phased and involving the gradual consolidation of physical labs and hosted virtual labs. And this is coming from one of our service provider customer using Cloud Shell capabilities. So the intent is to gradually make your lab more cloud-based by reducing in the first step your physical assets, then consolidating those physical assets and centralizing also your virtual assets, and finally, as an in-game, completely deliver your lab as a service.
Thank you, Pascal, and thanks to both Aaron and Jim. I'm going to summarize the conversation that we had today before opening up for questions. So I just wanted to share a few things. First of all, as we saw, as an industry and as vendors and as service providers and as consumers, we're all seeing a tremendous amount of interest in software-defined architectures. SD-WAN happens to be something that's more predominant in the context of enterprises, NFV in the context of service providers, and there's a significant amount of investment going on across the industry in this. And as we also saw, there is a fair amount of overlap in the problem statement as well as the motivations to solve them. And with that, what I wanted to just share was, first of all, these things that we talked about, NFV, SDN, SD-WAN, they're all extremely important tools to help both service providers as well as enterprises to become a lot more agile and thereby a lot more business relevant and business competitive. And all of you who are listening to this webinar, you can take some of the best practices from here and see, based on the thoughts shared by Jim as well as Aaron, and in the way that Pascal summarized it, what can you do to take actionable next steps. The next thing was really around blueprinting and cloud sandboxes. So today, one of the bigger challenges to move to the next level is to be in a position to validate and certify the compliance, particularly when you run into brownfield environments and where you want to mix the new versus the legacy. And here, the notion of using sandboxes to blueprint and then using that as a way to standardize and scale becomes extremely impactful. The third, we talked about use cases, and to really look at your use case and the corresponding architecture that best meets it for maximum benefit. There's still a lot of noise out there in the industry, and it's very easy to pick out something which may or may not be relevant to the problem that you want to solve. So again, here is where a blueprint can be defined and tailored to a certain use case. You can work through it in the context of your workflow, and then when you're ready, move to the next level. So with that, I just wanted to share that we have a survey open through this year. It's really about adoption of cloud and DevOps. It's a short 3-minute survey that should not take a lot of your time. I would encourage you to go click on the link on the bottom of the screen and fill that survey in. And again, we award gift cards every month for people that are filling the survey, and there is a drawing at the end of each month. If you want to get in touch with any of the 3 companies, obviously you can look up the websites. Verizon needs no introduction, obviously, but I also wanted you to follow us on our respective social media handles as you see fit, and any of us would be glad to respond to you with questions. And with that, let's open it up for Q&A at this point. We will see what some of the questions are that are coming in, and we'll try to address as many as possible in the context of this call. Jim, maybe the first one's for you. Could I reuse existing hardware with NFV, or do I have to purchase new hardware? Do you want to take a quick shot at that?
Yeah, sure. So that's actually a really good question. So we've done at Verizon some research into this because we understand that most companies will have a large investment in their infrastructure already. And so we've identified both specific devices that can be reused for NFV, as well as criteria potentially for other devices that maybe we haven't specifically tested. So if you have some devices that meet a set list of criteria, then yes, they can be reused with NFV. And then also, of course, there's new hardware coming out that's specifically designed for this.
Okay, I think that really helps drive both the innovation as well as keep the costs down. Pascal, I think you touched upon it, so this one's for you. Perhaps you can elaborate on it a bit further. What type of cloud technologies you support with Quali's cloud sandboxes?
Yes, so we're supporting both public and private cloud technologies, and I know a lot of service providers are relying on OpenStack, but this is not the only cloud solution out there. And as you're evaluating multiple private or public cloud technology, or maybe a hybrid cloud technology as well, you need to have the flexibility when deploying the sandbox to choose which cloud you're going to use, and then compare and contrast between different types of clouds. So this is something that we take into account.
Okay, there are another couple of questions. Aaron, maybe I'll direct this one to you first. I think it picks up on the CloudGenix tagline that you shared of networks without networking. So what exactly do you mean by that?
That's a funny question too. I mean, we always get that one. How do you build a network without a network? To be honest, the networks without networking doesn't mean you completely toss networking out. What it means is that if you look at networking protocols as they've been designed since the early days, it's all about scalability and scaling to internet scale, service provider scale, of being able to, one device only knows about all of its peers. What we do is instead of doing standard networking protocols to figure out where things are going, we use application flow information. So we send stuff on a path based on networking information, but then we track the application performance. And using that application performance of those end user experiences we use that to make future forwarding decisions and or move applications to different networks in real time.
Good. So speaking of applications, maybe this is the question that is sort of relevant to all of you. It talks about the way the roles are changing within the context of an organization. So I'll ask each one of you to chime in and give your perspective on it. So with regards to SDN as well as NFV, we're seeing an increasing affinity towards application. So do you see the network still being relevant, and if so, who is going to be responsible for the network? Maybe you can elaborate and probably give your perspective in a broader sense if necessary. Aaron, you want to take
Sure. So that's actually a really good question, and we've had a lot of data actually on this. We've had about 4 or 5 customers start to deploy virtual solutions where they're running a complete x86 a standard server out on the branch and replacing all their network hardware with the server. And one of the funny things that comes up is as you're going through the network team and deploying this, all of a sudden the server team ends up being the one that's tasked with managing the server, and they're wait a minute, I didn't have this responsibility before of managing a server in a branch and keeping the network infrastructure up. Now all of a sudden my fiefdom is changing. So there is definitely that task as you start going out with these virtual CPEs. It says, well, now who's going to actually be in charge of this? And it varies from organization to organization. That's actually an organizational hurdle that comes in for these type of virtual CPE and COTS branch deployments.
Jim, do you have any thoughts on that from your perspective?
Well, I think that we're a little biased to say that, of course, the network is always going to be relevant. The network is what powers all of the innovations that we've seen recently in things like cloud computing. I think what's going to become less relevant is who owns and operates the network. The network will, continue to fade into the background as a series of services that you purchase potentially from multiple vendors.
Yeah, that's actually a really good perspective, and in a lot of ways, as I've seen through in the industry, today we're seeing the growth of mobile IoT, and in all of these cases, the network continues to become increasingly relevant, and maybe the boundaries blur. I don't see it fading out of relevance anytime soon.
Yeah,
Pascal, you can comment on that as well as the applications in the context of the sandbox.
Yeah, certainly. So what we're seeing is that it all ties into this DevOps movement where the developer is now in charge of deploying not just the application as we understand it before the backend application, but everything becomes an application in this software-defined data center, including network functions. And as such, in the Cloud Shell Sandbox, we can model a network function just like you would model another virtual application.
That's well said. The industry is moving towards infrastructure as code and everything as code. So the boundaries are certainly blurring. I would like to, with that, conclude the Q&A session and also encourage you to register for some of the upcoming webinars. The next one's really going to be taking a deeper dive on Cloud Shell 8.0. This is somewhat more product-centric, but then we just announced the general availability of support of these sandboxes on OpenStack as well as Microsoft Azure. Obviously, this extends upon what was already existing with vCenter as well as AWS and Bare Metal. So that should be an interesting one. That's with Eden Eventhal, our VP of Engineering, so he's going to provide an engineer's perspective. So you can go ahead and register for that one. And for those of you in the financial services industry, if you're looking to take a similar argument and discussion as we had today about compliance for IT infrastructure, particularly in the context of financial services application, we're going to be having one soon. Look out for this on the Quali website in the next couple of weeks. And finally, with that, I would like to thank our panelists today. You brought in a lot of thought leadership and subject matter expertise as well as experience. So thank you so much for that, Jim, taking time out from your schedule. Aaron, you as well, being here in the Valley. It was good of you to take some time out from the growth that CloudGenix is experiencing to be on with us, and Pascal to you as well. I hope you enjoyed the webinar. Reach out to us with any questions. Thank you. Have a good day.